Lesson 14, linear relations. So what we're talking about here is we're talking about X and Y. We're talking about a relationship between those two. And we're talking about graphing, either lines or just a series of dots. So let's start with an example. Let's talk about depth and water pressure. So as you go down in the water pressure increases. So for instance, we'll have depth here on this column, and we have water pressure on this side. And these are just values that we've made up. So what we have here also is we have depth as an independent variable and water pressure is dependent. Because you think about this, the water pressure depends upon the depth that you're at. Okay, so we have our chart here. So the depth, as you can see, 0, 5, 10, 15, 20, and the water pressure goes up also. So let's graph this. So depth is on the bottom, which is your independent, and your water pressure is your dependent on the side. Now, the easy way to remember this, if you see it looks like it forms the word did, so dependent, independent. That's a great way to remember that. And we go up by scale here. We go up by 5 on the bottom on the X, and we go up by 50 on the Y. And then we plug in the points. So 0, 0, 550, 10, 100, and so forth. Okay, so we have these dots on here, 1, 2, 3, 4, 5. Now, here's the question. Do we join the dots together to form a line? Well, we can talk about either discrete data or non-discrete data. So let's talk about non-discrete first, because that's what the example is. Join with a line because the values do exist between the points. So think about this for a sec. You don't automatically start at a depth of 0 and then jump to a depth of 5 and then jump to a depth of 10. No. You progressively have to go down, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So we join those points together. So this is known as non-discrete data. So it's joined with a line because the values do exist between the points. That's the bulk of when we really get into graphing. You're always going to be drawing lines for your points. Now, discrete data, we'll explain that here, is not joined with a point because the values do not exist between the points. And if you want to see an example of that, let's go to page 2 and we can look at this one here. So what we have is we have boxes. We're talking about perimeter. So it's a rectangle. And the perimeter is the distance around it. So rectangle number 1, right? There's rectangle right here. We got 1, 2, 3, 4. 1, 2, 3, 4. And then perimeter. So we add up everything. So 1, 2, 3, 4, 5, 6. So the perimeter on this first one is 6. Okay. Rectangle 2, perimeter is 8. Rectangle 3, 10. Rectangle 4, 12. So we just add them up. Okay. So now we can look at independent, dependent. The perimeter depends upon the rectangle. So the rectangle is the independent, so that's going to go on the bottom. Remember, DID, dependent, independent. So the rectangle is going to go on the bottom, and the perimeter is going to go up the side. So we plot our points. 1, 6, 2, 8, 3, 10, 4, 12. Now, here's the question. Do we join these points together? Well, no, because rectangle number 1 has a limited perimeter. You can't have like 7. 7 for a perimeter will not work on this one because we're using the squares. So we have points there. We do not join them together. So this is discrete data. Do not join it together. And then what you can do is you can then take that and you can turn that into an equation. So what we have here is we have R for rectangle, P is for the perimeter is 2 times the rectangle plus 4. So let's see if this works. So the first rectangle number 1. So R is going to be 1. So we plug in 2 times 1, which is 2, plus 4, which is 6. Great. Now, don't just stop there. Always do it twice to make sure it works. So rectangle number 2, we should end up with an 8. So 2 times 2 is 4, plus 4 is 8. Yeah, it does. So it works in this case. Okay, so go to page 3. So that's an introduction to the standard way we graph, and that's slope-intercept form. Slope-intercept form, you'll often hear it as y equals mx plus b. And all these are letters that represent things. For instance, y just represents a point on the y value. X represents a point, x value. And the other ones, m and b, they have very particular things. So m in this case is the slope, and slope is basically rise over run, right? If you go tobogganing, or skiing, and you go down a hill, right? There's a certain drop in y over a certain run of x. The pitch of the roof of your house has a certain rise and a run. Stairs in your house, risers and runners, right? And then b is wherever it crosses the y-axis. It's known as the y-intercept. So y equals mx plus b, there's our breakdown of our 4 things. So let's look at an equation. You can actually see how it works. So y equals 3x minus 5. You can see right away, the negative 5 is the y-intercept. That's where it's going to cross the y-axis. And the slope is 3, which means it's positive. So it goes up 3, 1 to the right. Up 3, 1 to the right. Now, if you don't understand that right away, you can always get by doing a table of values. And table of values is just a little t chart here on the side. We have x and y, and we just pick some values of x. And pick nice values of x. Like don't pick 100 or negative 3,000, right? Pick 0, 1, 2. You can pick like 0, 1, positive 1, 2, negative 2, whatever you need. And then all you do is you're going to plug those into the formula. So we're going to take 0. We do that down the bottom here. Y equals 3x minus 5. So we plug in 0, so 3 times 0, and then minus 5, so y equals negative 5. So yeah, 0, negative 5. There's our point right there. Bang. So then we plug in 1. Y equals 3x minus 5. Plug in 1. 3 times 1, right, is 3 minus 5, negative 2. Yeah, there's our value there. So remember, you do the x first. You always start at the origin, and you do the x. So we go over 1, positive 1, and then down negative 2. And that's our second point there. Well, you do the last one here. Y equals 3x minus 5. Plug in 2. So 3 times 2 is 6. Minus 5 is 1. So our point is 2, 1. Again, start at the origin. The x value is positive 2 over to the right, and then up 1. Okay, and then we join the points together. And you see there's arrows on either end. Okay, and if you notice you did it correctly, it should form a straight line. So interesting thing is this is like a check. If you get one of these answers wrong at the bottom, you'll notice right away because your graph will not work. But you can look at a couple things. Y equals 3x minus 5. Negative 5, yeah, that's the y-intercept. But the slope, 3, and that's 3 over 1. We just don't write it in, right? Mathematicians are kind of lazy. They don't bother doing that. So they go 3 over 1. What that means is we go up 3, so 1, 2, 3, and over 1. Ah, there's the point. And then we go up 3, 1, 2, 3, and over 1. And up 3, 1, 2, 3, and over 1. You can actually see it's like a set of stairs going up, and that's rise over run. Okay, turn to page 4. So here's a graph, and let's talk about this. So the graph is y equals mx plus b. So it's in that form. We don't have to rearrange it. So y equals negative 2x plus 3. What is the slope? Well, what's in front of the x? Negative 2. Now, the negative means we go down negative 2 and 1 to the right. We always go to the right. And the y-intercept in this case is 3. So there's two ways of doing this. You can either look at y equals mx plus b and graph it based on that. Okay, yeah, b equals 3, so it's going to cross at positive 3. The slope is down 2, so we go down 2 over 1, and then you could graph the line. Now, if you don't understand that, you can still do a table of values. It will always work. So set up your x and y, pick some values of x. Again, pick nice values of x. So we picked, in this case, 0, 1, negative 1. And then what we do down the bottom here is we plug in 0, we end up with y equals 3. We plug in x equals 1, we end up with y equals 1. We plug in x equals negative 1, we end up with y equals 5. And there's our points. 0, 3, 1, 1, negative 5. Negative 1, 5. Plot the points. So start at the origin. 0, 3. 0, we don't go left to right. We just go up 3. Bang, we put the point. 1, 1. We go 1 to the right and 1 up. X first, then y. Go back to the origin again. Let's do negative 1, positive 5. So negative 1 is to the left. Positive 5 is up. Yeah, it works. You see how it forms a nice straight line? Connect the points, put arrows on the end, and you finish graphing that line. So there's two ways of doing it. Either base it just on the y equals mx plus b and do the slope and the y-intercept, or you could do a table of values. That also works. Both of those are great methods. Okay, flip to page 5. Y equals negative 3x plus 6. Again, two ways of doing it. So we could look at this one. It's in the nice form that we want, y equals mx plus b. So we look at here and we see the slope is negative 3 because that's in front of the x. So that means we go down 3 over 1, down 3 over 1, down 3 over 1. And the y-intercept is positive 6. That's where it crosses the y-axis. So you could look at that and graph it that way. So we can go, yep, y equals 6. There's the y-intercept. And negative 3 means we go down 3 over 1. And you can keep doing that. Down 3 over 1. Down 3 over 1, right? It works every time. If you don't work with that method, just do a table of values. It works 100% of the time. So x and y, set up your t-chart, pick some values of x. So in this case, we pick 0, 1, and 2. Doesn't matter what you pick, just pick nice numbers. Plug them in. We plug in 0, we end up with y equals 6. We plug in 1, we end up with y equals 3. We plug in 2, we end up with y equals 0. There they are there. So let's go back. 0, 6. So 0, start at the origin. 0 means we don't go left or right. We go up 6 for the y value. Bang, there's our point. Go back to the origin. We're going to do 1, 3. So 1 means we go 1 to the right, right? Because that's the x value, and then the y is 3. There's our point there. And the last one, 2, 0. We go 2 to the right, that's the x value, and 0, we don't go either up or down, so there's our point. And again, it works, forms a perfectly straight line. Okay, so that was lesson 14. Now you can do practice number 14.